Okay, today we are looking at section 5.52, and we're going to be looking at how to find determinants and inverses of matrices. We're only going to be doing this for 2 by 2 matrices and for 3 by 3 matrices. They have to be square matrices, meaning 2 by 3 is not square because the numbers don't match. So to find the determinant of a square matrix, here's the symbol that we use. It almost looks like absolute value, but it's not. It's just these two bars. Does not mean absolute value. For matrices, when it looks like this, it means that you're finding the determinant. Now, if we have this 2 by 2 matrix, and we're calling it matrix A, and the entries are A, B, C, D, then what we do to find it is we just kind of make an X. So the determinant of this matrix is going to be going this way. We do A times D minus B times C. So in example 1, we're going to go across diagonally down to the right, and we're going to do -4 times -6, that's 24, minus, and then we're going to go backwards, and we do -5 times -2, and that's 10, and so this determinant is going to be 14. So it's a pretty easy process. You should try the next one. We're going to get 4 minus, go backwards, 6. That's going to give us -2. Now on the next one, we're trying to find out what is that missing entry. So we're going to do -2 times x is -2x minus -3 times 4 is -12. Be careful with that. That would turn into +12. And that has to equal that determinant. And that determinant is 10. So now solving this, we're going to get -2x equals -2 after we subtract this out. And so x then is going to be 1. So if that entry had been 1, then that would make the matrix work out correctly to have that determinant. Any other number, we're not going to get that same determinant value. All right, so now we're looking at a 3 by 3 matrix. Now this gets a little bit more confusing, and we're going to use this process called expansion by diagonals. We have to be able to multiply out all of the diagonals. So we have to be able to go forward, and we have to be able to go backwards, and we have to make sure that we count every entry. So what we have to do is we have to rewrite those first 2 columns. So I'm rewriting the first column, and now I'm rewriting that second column. And now I can take care of every single entry. Now I have it all written out, but just understanding the pattern is easier. So we're going to multiply all of those values together, multiply all of those values together, and then one more time, multiply all of those values together. And we're going to add all of those products up. Now we're going to go backwards. Every time we go backwards, we're going to subtract, just like we did with the 2 by 2. So we're going to multiply all of those together. And we're going to keep going backwards on these diagonals. Now I have it all listed out, like I said, with the actual entries, but it's just a lot easier if you understand the pattern. So see how we're going backwards. It's just a pattern that you're following. So looking at this first matrix now, I'm just pointing out how that's the name of all of those entries when we're going backwards. See how that's just all of those entries, we go forwards, they're always addition, backwards, subtraction. So again, on this one, first we have to rewrite those first 2 columns. After we rewrite the columns, we're going to go forward. Now we're multiplying all of those together, we get 9. Multiplying all of those together, we're going to get 32. Multiplying all of those together, and we're going to get 12. When we go backwards now, we're going to be subtracting all of these. Each one of these has to get subtracted, so we've got to be careful with this. So we're going to do minus, and then that's going to be a -12. Put that in parentheses. Then we're going to have minus, and that's going to be a -36. And on the last one, that's going to be -8. And so if you want to get out a calculator at this point, you can, or you can just figure it out. That's going to be 41 and 12. That's going to be 53. And then we're going to have plus 12, plus 36, minus 8. What's that going to give us? 65 and 36. That's going to give us 101 minus 8. That's going to give us 93. Okay, so 93 is going to be the answer to that. Now, I want to show you how you could also have the calculator find a determinant for you. So you can go under matrix like we did before. You're going to put in matrix A. We'll just put it in there. This is a 3 by 3 matrix. Put in the entries, 3, the original 1, 2, 2, negative 2, 1, 4, 4, negative 3, and 3. All right, now we have to quit. We're not going to delete. We're just going to quit. So we go to second mode to get out of there. Just double checking it first. Okay, so we quit. Now we're going to go back to matrix, and we have to go over to math. And I have to find that word determinant. Determinant's what we're trying to find right now. So we want the determinant, and then where did we put that matrix? Well, we put it into matrix A. So I have to go under matrix, and that's my second, and x to the negative 1 to get to A. So now I look and make sure it says what I want it to say, determinant of matrix A, and it tells me it's 93, and that's what we got. Okay, so you want to be able to do this by hand and also on the graphing calculator. All right, let's look at the next one. So we're finding this determinant. We just rewrite those first two columns. Okay, so we're going to put that negative 5, that 4, negative 3, 0, 2, 5, and now we should be good to go. When we go forward, we're always going to be multiplying those, and then we're going to add those products. That's going to give us 60. And the next one, anytime we have a 0, it's going to be 0. That makes it easy. Next one's going to be 0 too, isn't it? Okay, going backwards, we're going to be subtracting. Another 0. Nice, easy enough. Go the other way, another 0. And looks like we're going to have a 0 on the last one. So that's a pretty easy determinant then. That's going to give us an answer of 60 for that determinant. We could check that on the calculator if we wanted to, but that one we're pretty sure on our answer. All right, so again, just making sure that we rewrite those two columns, and so that then once we rewrite those two columns, then we can just keep going with finding that matrix. You might want to go back and try that one on your own just to make sure. Okay. All right. So when we go forward again, we're always multiplying, and when we go backwards, we're going to be subtracting. We're always adding all of those when we go forward, subtracting when we go backwards. All right, you might want to even pause the video now and try this one on your own, or you can watch if you want. Rewrite those first two columns. And on the first one, we're going to get negative 8. Next one, we're going to get 5. And we're going to get minus 18. Now remember, when we go backwards here, we have to make sure that we subtract. So we're going to get minus 3, minus 4, and minus 60. Okay, and at this point, we can just combine all of these. Those are all negative, so we're basically just adding all those numbers. That gives us negative 10, negative 70, what is that? Negative 88. Okay, easy enough. If we want to check it, practice this. You want to be able to check it on your calculator. So first you got to put that matrix in. You're going to go under matrix, 3 by 3. You're going to put it in. Make sure you quit. I like to have a clear home screen, so always make sure that's clear right now. Then I go back to matrix, determinant of matrix, and wherever I put it into A, negative 88. So we're good. All right, so now we're going to look at why is it we even care about finding these determinants. Well, the determinant allows us to find the inverse of a matrix. The inverse of a matrix is going to allow us to actually solve systems later. So we want to be able to find the inverse to help us do that. So here's the process. If we have a matrix A having entries of A, B, C, D, and as long as that determinant is not equal to 0, then the inverse of the matrix, which is written like this, A to the negative 1, is going to be 1 divided by the determinant of A. And now look at this pattern. We're going to switch those A and D's, and we're going to change the signs on the B's and C's. So in other words, we're going to find the determinant first. Then we're going to switch the location of A and D. Then we're going to change the signs on B and C. Lastly, we're going to divide each entry by the determinant. So now we are going to find the inverse on some of these matrices. So on this first one, the first thing I have to do is find the determinant. So I have to do 2 minus -3. That's going to give us 5. And so that's going to tell us the determinant. Now remember that pattern that we talked about. So we're going to have to switch those two. The D and the A get switched. Then I have to change the signs on those two. And now we have to divide each entry by the determinant. So when I do that, I have to divide every single one, or in other words, you can think of it as multiplying it by 1/5, or just dividing by 5. So 2/5, -3/5, 1/5, and 1/5. Okay, pretty easy, right? All right, let's look at another one. Well, actually, let's check it on the calculator first. So we're going to go to our matrix, and I'm going to go over to edit. And this is the original one is a 2x2 matrix. We're trying to find the inverse of that original matrix. Put in those entries. Once you've got that in there, now we want to find the inverse. So we're going to have to go under and find that matrix. And now I want to do to the -1 power. I want to do the inverse. Well, that's right there. See that X to the -1 button? That means to find the inverse. So I'm finding the inverse of my matrix. I'm going to hit enter. And that doesn't look exactly the same. Those are decimals. They're equivalent. But if I want it to look exactly the same, I can just go under math and frac. So math bracket, that's going to change the decimals into fractions. And now we can see that our answer is correct. Okay, so the calculator is very helpful. We want to be able to do these both ways. If you ever take linear algebra in college, which is what math majors have to take occasionally, you're going to want to be able to do this both ways because you'll be expected to do that. All right, we're going to go down to letter C next. So to find this determinant, we get 20 minus 20. That determinant is 0. Remember what we said up above, that if that determinant is 0, the inverse does not exist. There is no inverse. So we're just going to put inverse does not exist. All right, so be aware of that if we get that 0 on that determinant, we don't have to go any further. We're finished. We can't even have an inverse. If we even tried to do this, watch what would happen. We switch everything around. We put our negatives in front of B and C. We can't divide by 0, can we? That's the reason why that inverse doesn't exist, because we're not even allowed in math to divide by 0. It makes a value that's undefined. So therefore, no inverse. All right, looking at letter B, we're going to go ahead and find that determinant first. So first we're going to do that determinant is going to be -7 minus -6. That's going to give us -1. And so now we're going to have to think about what that pattern is that we do. So what we have to do is we have to switch that A and D. So the -1 is going to go in the A spot, the original A spot, and then the 7 is going to go down there. And we switch the signs on B and C. And now we have to divide by that determinant. And so we're just dividing by -1. And so then our inverse is going to be +1, +3, -2, -7. And there's going to be our inverse. Okay, pretty easy, right? We'll check it on the calculator, and we'll practice putting this one into, we're just going to use matrix A again. We could put it into B if we wanted. So we're just going to enter that in. And once we have it in there, we're going to have to make sure we push enter every time. We're going to quit, we're going to clear. And then we're going to go over to math, and we want the matrix A first of all, and we're going to do the inverse of it, and we can check it, and we can see that we're correct. We also could have put that into matrix B if we wanted to keep that matrix A where we had it. All right, so not too bad with that. So the last thing that I want to talk about is looking at a problem like this. So why do we care about matrices? Well, it's going to help us to solve systems. Let's say we have this system here. So what I can do is I can write these first two the first part of this as a matrix. So the coefficients of x and y become my first matrix. X and y are what I'm solving for. So if I call that matrix A and that matrix B, the way I can solve this system is I can actually do the inverse. That matrix XY is going to be equal to the inverse of matrix A times B. So this is just another way that we can solve systems. And you learned how to solve systems in Algebra 1, and we've talked about it this year. So into matrix A, I'm going to put in the matrix 2, 1, 3, -2. I'm going to quit. And then into matrix B is going to be a 2 by 1 matrix, 2 rows, 1 column. So we'll have to put that in as a 2 by 1. And we've got our values of 1 and 4. And so now clear the screen out. And to solve for x and y, I go back to matrix. I'm going to do my a to the -1, that's the inverse, times matrix B. And that's going to give me this answer. That's going to be the solution. Now that's a really ugly answer. I can math frac it and I can get these solutions. Those are going to be the solutions to x and y. That would have been pretty difficult to do by any other method, like substitution or elimination. We can do it that way. What I can do is I can multiply that top matrix by 2. And when I do that, I will have a system where I can add these two together to solve for x. So when I add these together, I'm going to get, see how I wanted the y's to eliminate? That's why I multiplied by 2. So now when I add these two equations together, I'm going to get 7x equals 6, and so x is 6/7. Now look at what we found. See how x is 6/7? So you can see how this could be very helpful if we're trying to solve a system quickly. Now this was an easy system to solve, right? But to find y, I would now have to substitute that back in, and that would get pretty difficult. Okay. So what if we had something like that we're going to solve on the calculator? Can you imagine trying to use elimination with that? Like first we'd have to eliminate the y's, and we'd have to eliminate the z's, and then the x's. That would be a very, very challenging thing to do. But if we set it up on the calculator and we just used inverses, it wouldn't really be difficult at all. So that's why we want to study these matrices, is because they can allow us to solve very challenging systems of equations. Okay, and that's what we'll be getting into. So on our next lesson, we'll be looking at how we can use matrices even more to solve different systems. All right, hope that helped. If not, be sure to get in touch with me and I'll be happy to help you.